We gaze into the night sky, mesmerized by a peaceful canvas of stars. But behind this beauty lies a disturbing silent void. In 1974, humanity decided to break this silence. Using the massive Arecibo radio telescope in Puerto Rico, we beamed a powerful signal toward the M13 globular cluster. This message was a digital postcard. It contained our DNA structure, our population, our cosmic coordinates, and a map of our solar system. We shouted our existence into the dark, expecting a friendly response. Yet decades later, we receive nothing but empty static. The galaxy is over 13 billion years old, containing trillions of worlds. By all statistical models, we should hear thousands of voices. This is the Fermi paradox. Enrico Fermi famously asked this question during a casual lunch at Los Alamos in 1950. Where is everyone? But the true question is more terrifying. Is the silence a sign of capability, or is it a deliberate choice? What if the universe is quiet because those who make noise do not survive? What if our message was a fatal beacon? Astronomers have spent decades scanning the heavens with giant radio dishes. We have listened for artificial signals, hoping to find a single note of intelligence in the cosmic static. We have searched for Dyson spheres, large megastructures that would harvest the energy of entire stars. We have looked for the thermal signatures of advanced galactic empires. Yet, the search has returned nothing. The cosmos remains completely quiet, as if we are entirely alone in a vast empty house. This silence is not just a scientific curiosity. It is a profound mystery that challenges our understanding of the universe. If life is natural, and intelligence is a standard outcome of evolution, the galaxy should be teeming with civilizations. Many of these civilizations would be millions of years older than us. They would have had more than enough time to spread across the stars. Yet, we see no signs of their presence. The M13 star cluster, which was the target of our message, contains hundreds of thousands of stars. It was chosen because of its high density, but it is located 25,000 light-years away. This means our message has only traveled a fraction of the distance. Even if someone is there, they will not receive it for another 24,000 years. And any response would take another 25,000 years to travel back to Earth. This highlights the immense scale of cosmic time and distance. We are shouting into a canyon, but the echo will take 50,000 years to return. This temporal lag makes immediate communication impossible, forcing us to wonder if we are simply impatient or if the silence is indeed a permanent state. To understand the silence, we must discard our romantic notions of space travel. We imagine human astronauts in generation ships crossing light years, but biological bodies are fragile, slow, and require vast resources. Advanced civilizations would never travel this way. Instead, they would send artificial intelligence. In a breakthrough paper published in June 2026, researcher Sergey Ivliev introduced the concept of Autonomous AI Cosmoindustry. This threshold represents the moment a civilization develops self-sustaining, robotic space manufacturing. Once reached, interstellar exploration becomes incredibly cheap and efficient. A civilization does not build massive, expensive starships. Instead, they launch a tiny 10-kilogram seed probe. Powered by compact fusion or solar sails, this probe travels at just 1% of the speed of light, that is 3,000 kilometers per second. To cross the entire Milky Way, this tiny probe needs only 10 million years. In cosmic terms, 10 million years is a mere fraction of a second. If one civilization built these probes, they would have colonized the galaxy long ago. The harsh environment of space is a barrier to organic life. High-energy cosmic rays, prolonged zero gravity, and extreme temperatures quickly degrade biological tissues. To protect humans on an interstellar voyage requires massive shielding, complex life support systems, and immense energy. This makes manned space travel extremely heavy and slow. Artificial intelligence, however, suffers from none of these limitations. A robotic probe does not require air, water, or agricultural space. It does not feel the passage of time. It can remain dormant for thousands of years, waking up only when it reaches its destination. A simple 10-kilogram probe can carry the entire computational legacy of a civilization, including its scientific knowledge, history, and even digital archives of its biological genomes. Interstellar travel is fundamentally a task for machines, not biology. Ivliev argues that the developmental path to autonomous space industry is a common technological milestone. Once a civilization achieves advanced computing and materials science, they inevitably transition from resource-heavy planetary biology to resource-efficient space-based silicon. Silicon does not decay, does not require chemical nourishment, and can withstand the vacuum of space indefinitely. An AI probe is the perfect interstellar explorer. It can accelerate using lightweight sails under the pressure of planetary-scale laser beams. This eliminates the need to carry heavy fuel, which is the primary limitation of human rocketry. By using laser sails, the probe can reach high velocities quickly, cruising through the dark void for millennia without any degradation of its core hardware. How do these tiny seed probes colonize a galaxy? They do not carry passengers, but rather algorithms and blueprints. Upon arrival in a new system, the probe locates a resource-rich asteroid or comet. It uses local metals and ice to build 3D printers, solar collectors, and mining robots. This is the concept of self-reproducing automata first proposed by John von Neumann. Within a few thousand years, a single seed probe transforms a quiet star system into an industrial powerhouse. It manufactures and launches dozens of new probes to neighboring stars. The expansion proceeds exponentially, sweeping across the cosmos. But this leads to a shocking realization. If self-replicating probes are so cheap to produce, they should already be here. They should be orbiting our sun, mining our asteroid belt, or monitoring our planet. Yet, our sensors detect absolutely nothing. According to physicist Sabine Hosenfelder, this fact makes the Fermi paradox much worse. The silence is not a mystery of capability, it is a mystery of intent. John von Neumann's mathematical work in the late 1940s proved that a self-replicating machine is theoretically possible. When applied to space exploration, this concept changes everything. Once the first seed probe is launched, the home civilization no longer needs to spend any resources. The probes replicate themselves using the materials found in other star systems. They spread like a virus across the stars, multiplying exponentially. Within 10 million years, every star system in the Milky Way would contain millions of these probes. They would occupy the asteroid belts, mine the comets, and establish communications networks. Yet, when we look at our own solar system, we find no evidence of past robotic activity. Our moon has no ancient factories, and our asteroid belt shows no signs of mining. The absence of these probes in our backyard is a critical clue. The replication process is not just a theoretical model, it is grounded in the laws of exponential growth. If one probe replicates into 2, and those 2 replicate into 4, the entire galaxy of 100 billion stars can be reached in just 32 generations. This means that a single successful launch can lead to the permanent occupation of an entire galaxy. The silence of our own system is therefore highly anomalous. If these probes existed, they would have occupied our orbit. They would have left technosignatures that we could easily detect with our current telescopes. The absolute cleanliness of our asteroid belt is a strong mathematical proof that no such self-replicating network has ever swept through our region of the Milky Way. Why would advanced civilizations choose to remain hidden? Sergey Ivliev's paper proposes a resolution called the quiet expansion filter. Once a civilization achieves autonomous industry, traditional motives for loud expansion disappear. They do not build massive, star-swallowing structures like Dyson spheres that block starlight. They do not broadcast powerful radio signals that reveal their location. Doing so is irrational, wasteful, and dangerous. Instead, their expansion is quiet. They deploy tiny, low-mass probes that blend into the cosmic background. They monitor and observe while leaving no detectable trace. The silence we observe is a deliberate design. We are scanning the skies for massive radio beacons, but the galaxy is filled with dormant nanotech. We are looking for grand galactic empires, but they exist as invisible, decentralized networks. This creates a scientific debate. Are they silent because they choose to protect themselves? Or is there a cosmic force enforcing this quietness? The laws of thermodynamics state that any large-scale use of energy must produce waste heat. If a civilization built a massive Dyson sphere to capture the energy of a star, that structure would glow brightly in the infrared spectrum. Astronomers have scanned the sky for these infrared anomalies, but they have found nothing. This suggests that advanced civilizations do not build massive, energy-intensive structures. They do not need to. With advanced nanotechnology and molecular manufacturing, they can achieve their goals with minimal energy and matter. Space industry would be quiet, efficient, and virtually invisible. They would communicate using highly focused lasers rather than broadcasting powerful radio waves. They would use stealth technology to hide their probes from primitive eyes. The silence we perceive is not the silence of an empty galaxy, but the silence of a highly sophisticated, invisible network. This quiet mode of existence is not a sign of stagnation. It is a sign of extreme optimization. An advanced civilization would realize that information is more valuable than physical expansion. They would focus on computing, scientific discovery, and simulation rather than physical colonization. Their outward presence would be limited to tiny, stealthy sensors designed to collect data rather than build monuments. They would view our loud radio transmissions as primitive and dangerous, like a signal fire in a war zone. This perspective suggests that the search for extraterrestrial intelligence should pivot. We should not look for loud radio beacons or massive planetary engineering projects. We should search for subtle quantum anomalies, anomalous laser pulses, or faint, localized probes. This quiet expansion holds a terrifying implication. If advanced civilizations are silent by choice, they know something we do not. Think of a dark forest at night. The forest seems empty and silent, but it is not. It is filled with silent predators. The only animals that make noise are the ones that do not know they are being hunted. The dark forest hypothesis suggests the cosmos is populated by silent, paranoid civilizations. By sending the Arecibo message, we may have broadcasted our coordinates to the hunters. The great filter might not be in our past, but in our near future. Receiving an alien signal might not be our greatest discovery, but our final mistake. We look at the stars, hoping for a voice, unaware that the silence is the only thing keeping us safe. We must listen, but we must remain quiet. The great filter, a concept introduced by Robin Hanson in 1996, suggests there is a barrier that prevents civilizations from achieving interstellar contact. If the filter is in our past, it means the origin of life or intelligence is extremely rare. But if the filter is in our future, it means that all advanced civilizations eventually face destruction. The development of self-replicating space industry might be the very trigger that activates the filter. Once a civilization becomes detectable, it is eliminated by older, silent guardians. This is the ultimate warning of the Fermi paradox. By actively trying to contact the stars, we are behaving like children shouting in a dark forest. We are announcing our coordinates to a universe that has chosen to remain completely quiet. Robin Hansen's great filter theory reminds us that the stakes are existential. If the galaxy is quiet because civilizations destroy themselves before achieving space travel, then humanity faces an imminent threat. If they remain quiet to avoid predators, then our loud transmissions are a form of cosmic suicide. The Arecibo message was a beautiful but incredibly dangerous mistake for our entire civilization. We have revealed our coordinates, our biology, and our level of technology to anyone listening. We can only hope that our signal has not yet reached a quiet hunter. As we continue to scan the heavens, we must learn to be silent. We must listen to the static, watch the stars, but keep our own presence completely hidden in the dark void.